You will see this chemistry question on your MCAT.
Question 7. Phosphorus appears directly below nitrogen in the periodic table. The boiling point of ammonia, which is NH₃, is higher than the boiling point of phosphine, which is PH₃. Under standard conditions, which of the following statements best describes or explains the difference in the boiling points of these two compounds? Okay. Now, what we can recognize first of all, okay, is that nitrogen in NH₃ is bound to a hydrogen. And we have to remember that when you have a nitrogen and a hydrogen in a species, this actually can act as a hydrogen bond donor. Okay, so it can accept hydrogen bonds because there's a dipole here, and the nitrogen is more, electronegative. But also, this is one of those three main species that can actually donate hydrogen bonds, the other ones being OH and FH. Okay, so if you ever see this, one of these in a group, in a molecule, you know it can act as a hydrogen bond donor. Phosphine, though, cannot. Okay, pH cannot act as a hydrogen bond donor, all right? And hydrogen bonds are very strong, like amongst the quote-unquote weak intermolecular interactions that determine physical properties, for instance, like boiling point, hydrogen bonds are amongst the strongest, okay? So if something can hydrogen bond, generally, compared to another compound that has a similar molecular weight, it is going to be expected to have a higher boiling point. So if we look at the answer choices, right, A, no, that's not saying what we were talking about. B is also not saying that. And then C is actually just generally wrong, okay? And then D is the only answer left, and this one says ammonia forms stronger intermolecular hydrogen bonds than phosphine, and this is correct, right? So D is our answer.